My name is Oktay. This video is about newest images of the James Webb Space Telescope. The telescope was named after James Edwin Webb. He was the second administrator of NASA in 1961 to 1968. And he proposed a large space telescope in 1965. This picture shows you the advantage of the James Webb Space Telescope over the Hubble Space Telescope. The James Webb Space Telescope has 18 hexagonal mirror segments made of beryllium and which are plated with gold. Its light collecting area is 25.4 square meters compared to Hubble's just 4.5 square. James Webb Space Telescope was deployed 1 year ago in December 25th in 2021. The Lagrange point L2 at 1.5 million kilometers distance. Lagrange points are gravitational equilibrium points of Sun and Earth. This is a picture of the Saturn's moon Titan, which is the biggest moon of Saturn and the second biggest moon in the solar system. It shows you the changes in the clouds over a period of 2 days. Titan has a dense atmosphere and clouds and rains. It has rain and rivers and lakes, but not of water, but methane, CH4. This moon has a circulation system comparable to that of Earth, but just with methane instead of water. This is a picture of the Protostar L1527, which is located 460 light years distance. This is a picture of a birth of a young star. And you can see these jets at the poles. And the ejections are sporadic, not constant. That's why you have these bubbles in the upper central region. This is a computer render of the star WASP 39 and its hot Jupiter planet. The star WASP 39 is a G-star like the Sun. It is located at a 700 light years distance. Its planet WASP 39b is a hot Jupiter. It's a puffy planet. It's bigger than Jupiter, but has just 28% of Jupiter's mass. Surface temperature is around 900 degrees Celsius. This is a spectrum from James Webb Space Telescope of its atmosphere. And you can see it contains sodium, water, carbon monoxide, carbon dioxide, and sulfur dioxide. This is a picture of the Carina Nebula. It was taken from the Kalahari Desert. The Carina Nebula is a star cluster and star formation region at 8,500 light years distance. Its diameter is 460 light years, and it has a companion, NGC 3324, which is an open cluster at 9,100 light years distance. This is a detailed James Webb Space Telescope image of the open cluster NGC 3324. And you can see the formation of young stars. And like in the case with the Protostar, you can see jets at the poles. This is a picture of a double star system, Eta Carinae, with two giant stars. Star A has a mass of 100 sun masses, and the star B 30 to 80 sun masses. They orbit each other every 5.5 years. And the ejections from the bigger star Eta Carinae A have created this nebula, which is called Homunculus Nebula. And this is material for future generations of stars. This is a picture from the Taranula Nebula NGC 2070. It's located in the Large Magellanic Cloud, which is a satellite galaxy of our Milky Way galaxy. The Taranula Nebula is at a distance of 160,000 light years. And you can see again this structure of gas and dust, and it's a star formation region. This is a detailed picture with the MIRI mid-infrared instrument of the James Webb Space Telescope. It shows you the star formation, and the blue and the purple parts are from hydrocarbon. This is another picture from the very large telescope, survey telescope of the dwarf galaxy Wolf-Lungmark-Melotte, which is located 3 million light years in distance. Its diameter is 8,000 light years. For comparison, the diameter of the Milky Way is 100,000 light years. The Wolf-Lungmark-Melotte Galaxy is located at the edge of the local group. The local group is our group of galaxies, with the three main big galaxies: Andromeda, number 1, number 2, Milky Way, and number 3, the Triangulum Galaxy. This is a picture of the James Webb Space Telescope. It shows you the faint stars, and this dwarf galaxy was named after Max Wolf, who discovered this galaxy in 1909. But Lundmark and Melotte later recognized that it was a galaxy, and that's why this galaxy has this name, Wolf-Lungmark-Melotte Galaxy. This is a picture of the galaxy IC5332 at 30 million light years distance from Hubble Space Telescope. It is a faint spiral galaxy with a small central bulge. This picture is from the James Webb Space Telescope, and it shows you the details of the spiral arms with complex structure. This is a pair of galaxies. It's called ARP-298, located at 220 million light years distance. This picture is again from the Hubble Space Telescope. The bigger galaxy is at the bottom, the NGC 7469, the spiral bar galaxy, not the same type of galaxy as the Milky Way galaxy. And its companion is IC5283. It's experiencing the gravitation of the bigger galaxy, and you can see it's a bit, this one arm is a bit stretched. These two galaxies are in the early stage of the merging process. This is a detailed picture of the bigger galaxy NGC 7469. Its diameter is 95,000 light years, which means it's a little bit smaller than the Milky Way. It's has an active galactic nucleus and has a starburst activity. The six-pointed diffraction spike is not a real object, but just a diffraction spike. And you can see in the bottom left the companion IC5283. IC1623 is another emerging galaxy pair at 270 million light years distance. It is at a later stage of merging. It has a high starburst activity, which is 20 times higher than the star formation in our own galaxy Milky Way. These are different pictures. At the left, you can see the Hubble Space Telescope picture. In the middle, the near-infrared picture from this James Webb Space Telescope, and at the right, the mid-infrared picture from again from the James Webb Space Telescope. And you can see each wavelength. At each wavelength, you can see different parts of the merging galaxies at higher detail. This picture shows you the future of our own Milky Way galaxy when it will merge with the Andromeda Galaxy in 4.5 billion years. And there's already a new name for the new galaxy. That's, some people call it Milkomeda. This is VV191. It's a galaxy pair located at 695 million light years distance. At the left is VV191A. It's an elliptical galaxy further away and very dim. And in the foreground, it's a spiral galaxy VV191b. And these two galaxies are have enough distance, so they are not in a merging process. They're just, from our point of view, they're in the same direction, but they're far enough away from each other. At the left, you can see here a picture of the extremely red quasar SDSS 165,202.64. And the James Webb Space Telescope has taken an image of this red cluster, and you can see pictures of the emissions from doubly ionized oxygen. And the gas cloud expands in all directions. That's why you have some of the gas moving away from us at 700 kilometers per second, and some of the gas is moving towards us at a speed of 350 kilometers per second. And this is a picture of the galaxy from 11.5 billion years ago. Quasars are luminous active galactic nucleus. This picture is made of doubly ionized oxygen effect, and it shows you the moving gas. This is a computer render of what a quasar could look like. It's a quasi-stellar object. In the center there's a supermassive black hole, which forces matter into an accretion disk around the black hole. And the material is heated up due to friction, and that's why it's so bright. Some of the material falls into the black hole, but other parts are ejected with this jets out of the black hole. And if the jets hit gas clouds further away, then they can trigger a star formation. This is a picture of the North Ecliptic Pole. That's just 2% of the sky area that is covered by the moon. And thanks to the James Webb Space Telescope, we can see previously unseen furthest away galaxies like this one. And the light from these galaxies traveled almost 13.5 billion years. This is a picture of the galaxy cluster Abell 2744. It's called Pandora's cluster. It's located at a distance of 4 billion light years. 70% of the mass is dark matter. It's not clear what dark matter is. And this galaxy number 1, this picture is from just 450 million years after the Big Bang, and the galaxies 2 is from just 350 million years after the Big Bang. And you can see back then there were tiny early galaxies that were about to merge to the bigger galaxies that we know today. This is another very impressive picture. It shows you in the middle Neptune at a distance of 30 astronomical units from the Sun. 1 astronomical unit is the Earth's sun distance, 150 million kilometers. This picture was taken with the James Webb Space Telescope near-infrared camera. And what is very impressive is this spiral galaxy. The James Webb Space Telescope shows its spiral arms. And this is very impressive because it could be that this spiral galaxy is as far as up to 1 billion light years. We will see in the near future more exciting pictures and scientific discoveries thanks to the James Webb Space Telescope. We live in a great time for science. And that was today's video about newest images of the James Webb Space Telescope. Thank you for watching. Have a nice day. Bye bye.